We are waiting for our attendees to join. Okay, we can start, and they will join us along the way. Hello, everyone. My name is Bojana, and I am here to greet you on behalf of Hello World. Thank you for joining us today on our today's topic. Here we have Evgeni, a project manager on automotive projects from Luxofta, and Nenad, who is also a project manager from TTTech. He is also assistant professor at the Faculty of Technical Sciences. Unlike usual, today I'm not going to be the moderator. We have Irena here for that role. So she will be our host today. I hope you will enjoy. And before we start, I would like to give you some service information about the webinar. So we are going to record it, and the video will be available on our YouTube channel. Everyone who signed up will receive an email from me tomorrow with this video. Feel free to use the chat to ask questions about today's topic, and you can ask the host, you can ask the panelists, so you get the answers about today's main topic. Once again, I hope you enjoy, and Irena, I give you the word for the webinar start.
Thank you, Bojana, for introduction. Hello, everyone. Thank you once more for joining this webinar. I would like to highlight that this webinar is in joint organization of Luxofta and Hello World, and we are very happy to have our colleague Nenadom Četićem from TTTech Auto as well as our guest. As Bojana said, during the webinar, you can ask questions in the chat session. So feel free, if you feel inspired, to ask our guests whatever inspires you. You can ask in chat, and we will try to cover those questions during the conversation or later in QA part. So welcome on board, and let's start. I think it's the best to start with the first question, which is like, why do we need autonomous cars?
Okay, so actually this is a very good question to start with. And yeah, because before we go too deep into the topic, we need to understand the motivation, yeah? And from my perspective, I would say to answer this question, we need to ask ourselves another one. Namely, what we don't like in just the normal cars, because this question is more specific to ourselves, and we can answer it more clearly. For me, for example, as a driver, I don't like the traffic jams because they're simply boring. Yeah, but you still have to pay attention to the driving, because otherwise it will be an accident. And accidents actually are the most terrible thing that I don't like in just the normal cars. And also I have the question to you guys and to the participants as well. So how do you think, how many percentage of the fatal accidents on the roads are caused by the human error? So by the human factor. So you can shot your guess, any guess?
I can guess majority of them.
Yeah, so I can see that there's...
Jovan is close.
Yeah.
100 probably. Jovan says 99%, but probably 100 of them. Yeah.
Yeah, so you know a lot. And actually, by the statistics, 94 and 94%. That means that we simply accept the thousands of deaths across the world on the roads, and we need to do something with that. And I think that autonomy can improve the situation significantly, because statistics gives us the hint that there is something with the human.
Statistics are ruthless, definitely. And with some authors, of course, what we are really talking about here is the root cause. When accident happened, do the analysis, and you figure out that somehow it ends with the root cause of a human error. And with some statistics and some reports even goes up to 98%, which is almost, Jovana, you missed it for 1%, but it's really, let's say, the functional safety or the safety of a car should be improved with autonomous vehicles. And this is really, from engineering standpoint, what we're trying to resolve here. So of course, some of the nice things that can come with this is the leisure time. I learned this comment from a colleague of mine, where he said that autonomous vehicles should be time travel, because you get back your time. You can read a book, or you can actually travel through time, and you just end with from point A to point B, doing something else, right? And this is really the dream that we are trying to do with offering this as a good, let's say, engineering advancement in existing vehicles, but also offering the systematic solutions in some cases with combining it with different technologies, smart cities, and etc.
Yeah, this is very nice.
This is the dream.
So it's not only safety, it's comfort as well, and getting back our time that we're spending.
Exactly.
Yeah.
And I would say that there is another reason, which we usually skip in these talks, but come on, we are on the Hello World podcast or webinar. And I think that one of the main reasons is that there are plenty of interesting tasks for developers. So that's maybe the major reason.
That is the topic that we will also cover here. Besides talking about autonomous vehicles, autonomous driving, how they will impact our lives, our cities, our future, we will of course discuss about the opportunities for everyone who is today interested in this webinar. How can you contribute to the future of automotive? And since we discussed about why do we need autonomous cars, let's proceed with the question, where are we now? How far we are actually from autonomous driving? Because all the time we think that we are near that, but are we so close, or what is the situation?
So yeah, maybe I can go first. I usually like to make fun of Elon Musk in this case, because he is solving it every year for now 10 years. So this year it's going to be solved by famous quotes from him. But here I would also like to share a screen briefly, because this is a famous Gartner curve. If you're not familiar with the terminology here, it's actually some kind of a model or predictability of the cycle where we go from introduction of an idea or introduction of a technology, and then through this hype, let's say, we go into this valley of disappointment. So I will try to briefly share this picture so that it's not a so dry explanation. So here's the thing. So this is report from last year practically, and this, you can see this triangle here where it says autonomous urban and mobility, right? The air mobility and etc. And you can see a lot of other stuff, AI in transportation and etc. But the main message here is that when idea is introduced, right, and we have this innovation trigger, we go and we hype about it. So there is always let's say an increment of an interest where you put your interest at the very peak, where we with autonomous vehicles are, in my opinion, somewhere after this inflated expectations. And then we need to be careful when we enter this tough time of this delusionment, but not to fall into what is also called the valley of disappointment. And then what we really want to do, go as fast as possible, right, is to set the correct expectation, go into plateau and do the proper engineering. So this is really, let's say, the main messaging here. But the other really important message here is that this is really reality, guys. This is happening right now, happening from Serbia, happening from the region. We are working on autonomous vehicles. And this is what Evgeni and myself try to explain in many different aspects and details, but it's actually happening now. But it's not a new topic. Roughly some 40 years ago, we had first computers actually driving a vehicle. So back in 86, I was 5 years old actually, back then. Not to reveal too much about my life. We had a Carnegie Mellon driver nav lab 1, and then 40 years after that, we now have assisted drive almost in every car that you can buy on the street. So everyone is actually on board, and now we need to talk about, let's say, how to move from this point to next points, and how to set properly the expectations, and how to overcome some serious engineering problems.
So when we are talking about the where are we now, we need to touch on the topic of the levels of autonomy. So we are always listening about those 6 levels of autonomy. So are there 6 levels, and where we're at now in this moment?
So yeah, if we are talking about the levels of autonomy, there is an international classification that you mentioned. And I would say that we are now somewhere in the middle. So the 0 level is just the normal car. It can be with some safety systems like ABS, anti-braking system, or some blocking system, or something like that. Level 1 is like smart assistance or advanced driving assistance systems. You could see the ADAS terminology. So basically, the system can control either steering or acceleration, deceleration, so the speed. And on level 2, which is the assistance, we have such a car like Tesla. So you are still responsible for the driving, but the car can cover some simple cases on the road, for example, on the highways. But nevertheless, you should react immediately if something goes wrong. And you cannot distract. And very significant leap is from step 2 to step 3, from level 2 to level 3, because on level 3 the car is responsible for the driving and you can distract. Still, it's conditional. We call this level also as eyes off, so you can close your eyes. But car can also request take over the control. For example, in a few minutes, there will be a tunnel or a roundabout that it's not capable to cover. Yeah, so you need to drive by your own. On level 4, we can close not only our eyes, but we can disconnect our mind. So we call this level as mind off. And yeah, so basically you can play some, I don't know, games like Cyberpunk on in the car or something like that. And level 5 is like driver off. So we can remove the steering wheel and it's completely driverless in any weather conditions. It's our far future. So now we are between level 2 and level 3. And the latest developments on the public roads is level 3 Mercedes S-Class. Mm-hmm. So it's officially allowed in some states in the USA and in Germany. Mm-hmm. So that's like the short description of the levels and where we are now. And actually, I remember one joke about not Elon Musk, but about the General Motors. So they promised even in 1959 that there will be a fully autonomous car in 20 years. So you can imagine that advertisements are quite aggressive. And we need to be careful with the forecasts and like more mature, as was shown on the diagram.
Yes, and when did it all start? Because this idea of autonomous driving is not new, even though now it's the hype is all around it, but actually it started many, many years ago, right?
Yes, in 40 1459, Leonardo da Vinci. I'm kidding, but you know, in each joke there is a part of joke. He invented the car that was pre-programmed like watches. Of course, it's not the full autonomous car, but you know,
it was executing a program. Yes.
Yeah.
Without too much sensing, but yeah.
Yeah. The first serious steps were made in 1980s. So there was a very famous project, and I don't remember the name, but it was in Germany. Prometheus, based on the Mercedes van. There were a lot of sensors on the car, like, I don't know, 80 or 100. But this car could already drive autonomously, of course, not on the public roads, and make some simple tasks like changing the lane or something like that. And Nenad, maybe you can mention the DARPA challenges, which are so exciting.
Right. So the somehow it bootstrapped at 80s, right? Carnegie Mellon 86, this Munich guys, exactly. I think Vamors or something like this with this van did practically the same thing, right? But it was, let's say, it was rudimentary in terms that it was driven really with a vision system, right? And it actually can detect the road and slowly, very slowly, move through this road. Then we have, let's say, Mercedes that actually did quite a big leap and actually executed something that was really stunning, but this is really the highway drive. And then the DARPA challenge, it's a little bit later than this is 205, the first DARPA challenge, where actually academia together with the industry created this challenge that everybody can, of course, with a proper knowledge and with the right funding, can go into the desert and compete with each other, right? And then there are really the mishaps and the flops, but there was, let's say, then recursive challenge every, I think, year or bi-yearly that they actually summoned again and measured who is better. They measured the speed, they measured the accuracy, some kind of an error pointing system, and then you have really, let's say, modern concept with the computer vision, with a lot of sensing, with the lidars, radars, and etc. And then it was really the cybernetic system on the wheels that is like a robot on the wheels that is trying to go through the desert. So this was quite big. And then, of course, Tesla 2014, I think, with the commercial vehicles, then Google with the Waymo, right? And then now everybody practically needs to have it to be relevant. And this is really where Evgeni and myself are helping with, with building the software and hardware for these big players.
And I really recommend to watch the DARPA challenges on YouTube or somewhere else, because for me personally, it was the source of inspiration, and that's why I'm here in the automotive industry.
And these days you can organize the challenge for yourself. What we did on the faculty, some of the colleagues of mine, they actually created the artificial road marking on the floor, and you can have for instance, NVIDIA board, a cheap one. You can put it on a toy car, and you can program it by yourself. It's not so far-fetched. So you can really download the code and try to execute it on your own. And of course, there are ways to do it on simulators and etc. But I always like to have a physical thing in my hand to see it going.
I would like to use this opportunity to encourage our attendees to ask questions in chat if they have some questions. And also, I would like to say that we already received some questions in advance while attendees were applying for this webinar, and I would like to cover those questions as well. So one of the questions that we got is what kind of drive or actually what kind types of propulsion are used in autonomous vehicles? So can you please answer this question?
Yeah, so basically the autonomous vehicles are disconnected from the type of the propulsion. So it can be deployed both on electrical vehicles, on combustion vehicles. Doesn't matter. Of course, there are some trends, and we see that there are many electrical vehicles emerging right now. And also there is approach. You can see actually several approaches how to build the autonomous vehicles. Some of the car makers just modifying the existing cars by putting the software inside. So they are developing the brains of the car. But some of the manufacturers or even startups decided to create the new vehicle from the scratch. So it's definitely electrical, plus it can be without the steering wheel, and like all the four wheels can turn and so on. So that they play with the design as well from the scratch.
Mm-hmm. Another question that we got from one of our participants is, can electric vehicles wirelessly communicate among each other? This is very interesting question, because I think it's basically the root of this of this problem, right? Communication between vehicles.
Yes, so the communication by some authors is going to be essential, basically, if you want to have a smart city, right? And if you want to really have all the advantages of technology, then we need to talk about 5G coverage. Unfortunately, we need to talk about many different stuff. And there are, of course, vehicle-to-vehicle communication, vehicle-to-infrastructure communication, and a lot of these, let's say, complicated terms that are there for explaining the problem. But in the simple words, we can actually illustrate it with, I don't know, with a cross section, for instance. If somebody is approaching a cross section, right, with all the sensors and all the, let's say, all the capabilities of your vehicle, you cannot be knowledgeable about what is coming from an orthogonal angle. If it's around the corner, you cannot see. And maybe there is an ambulance or maybe a fire truck, right, that is approaching. So system should be smart enough to actually change the lights, but also to signal to the vehicles, maybe without too much of interaction with actuators, but to signal to the let's say participants in the traffic that some emergency is coming, right? This is, let's say, not connected completely to autonomous vehicles, but it's a nice example where we can see the benefit from a connected car, of course. And for us, connected car and wireless communication is super important if we also want to have, let's say, modern systems and modern software. Now the connected cars are also important for things that, for instance, Tesla is doing already. So you have the over-the-air updates, right? You can receive a new version of a software. This is happening completely while you're not driving, right? So you have the update of the system prepared, and you just accept it, right? While you are not driving, and then voila, you have the latest and greatest system. So this is really spectacular in terms of advancements, right? The only way without such a feature to actually update the vehicle is go to the shop and go to expensive work on the car to apply with the probes and try to reflash it or try to update it. But of course, with a connected car, there is a big danger of called cybersecurity, right? So you don't want to end up with the malicious updates, and somebody can hack your car, somebody can really do a nasty stuff. And this is also, you can read from time to time about this in the news.
So all of that are actually challenges related to this topic. And what are actually the other main challenges of a modern software development environment?
Right. So when we're talking about the modern software development, let's set the stage first. What we are really talking about. So everybody these days is talking about agile development, for instance, or this lean process, or updatable, right, things. Then we are talking about the software quality. What kind of verification, what kind of testing you can really do to reassure that your software is well designed and is well written, right? And these are really the modern, let's say, modern aspects how we do stuff. We do it through continuous integration, we do it through continuous deployment, and etc. But these are really not so new concepts. For instance, TDD is really old, like decades old. They did it with the punctual cards, basically. And this, let's say, now that it's modern, it's actually vivid how the whole developer community is discussing about it. These are really the old concepts. But what is modern? Modern is that you can actually, from your desk, right, access the development center, access some racks, and update the software from your PC, right? You don't have to go into the lab and hook the equipment and stuff like this. And you want to have the increments in one sprint, in 2 weeks. You want to be able to code your new feature, set into a car, and drive it around the street. This is something that we were trying to do in Munich, that we actually can verify that this software or new increment works. So the big challenge there is how to actually meet this traditional automotive process and all the standards, all the things that are necessary for you to actually have a mature technology to go with a street approval and to go into serious grade maturity, and complete what is called in our colloquial rounds a mini V, right? That you go through the mini waterfall as quickly as possible, and you do everything. You update the documentation, you increment your tests, and you are really done with your work. It's still a not solved problem. We are struggling with it, but it's fun. It's something that we keeps us awake, and we're trying to find a solution.
Evgeni, I would like to ask you, why don't we have fully autonomous cars yet? What is the main obstacle for that for now?
Actually, there are a lot of them, and one of them is actually Nenad started to discuss. And from my perspective, the most challenge, sorry for tautology this and this wording, but for me it is testing, because we need to prove for the wide audience, for the public, for the government, that the car is safe. And to prove this, we need to drive like hundreds of millions kilometers without any accidents. And it's not enough to drive only on highways, or I don't know, somewhere where you don't have the pedestrians or any other cars. You need to cover a lot of different cases, and it's hard to find. I mean, some corner cases, but they might happen in the real world rarely. And actually, the challenge here is to collect a lot of data and to prove the safety. Of course, it's not unavoidable. I mean, it's not the challenge that we cannot overcome. For sure, we will, but it takes time, and it also needs some different creative approaches. For example, simulation can help here a lot, because in simulated environment, we can even create the cases that we face, I don't know, just in the real world once per year. But, you know, if we are talking about the life, every case is important.
Mm-hmm. And Nenad, what do you think? What is preventing us today from having fully autonomous?
So there are many challenges. Of course, fully autonomous, main, let's say, impediment for the level 5 would be really to change the infrastructure, because we cannot really have let's say safe environment, completely safe environment that covers all the cases. So something really significantly will need to change with how we manage traffic to really fully have autonomous systems. Some level 4, level 5 systems are existing right now, but again with a really constrained environment. On the airport where it's actually fenced completely, you can have autonomous vehicle or autonomous robot that is actually fenced completely from everything, right? So that if there is, let's say, intrusion, the whole system stops, and until this safety critical situation is avoided or mitigated. If you have, for instance, these robots from somebody was mentioning in the chat, Amazon is also really powerful and making some really good improvements in the subject. They are using these autonomous robots in the warehouses, where they actually have a system to distribute the packages completely autonomously, right? With a big neural net controlling and orchestrating practically the traffic. But for us to go on the road with everything that is actually unpredictable on the road, we will have the challenges that are beyond our current grasp or philosophical grasp of understanding. Because if you put an autonomous vehicle in the traffic, people will behave a bit differently. I don't know, I cannot imagine really in this simulation partly being able to let's say comprehend, but this situation where we have, I don't know, 50% of autonomous vehicles, people will react to this differently. Pedestrians will react to this differently. This is a completely then a new system that we don't know about yet, right? And then with the augmented simulated stimulus, for instance, for deep learning, in the literature there are pitfalls that are already known. With the synthetic data, you can have some improvement, but it's still not enough. And then what is really happening right now, everybody that is really serious about the topic is actually introducing a fleet of vehicles that is live on the street and collect the data. And then we need to collect the data in a smart way. For instance, internally, we have something that is called intelligent data collector, that we can configure it and put a certain trigger to record certain event. And then in the factory or in the engineering lab, you can actually use this segment to train more on your data, right? So this is now what we are really doing. We're trying to deploy technology inside of the real vehicles. We have concepts like completely 2 different parallel stacks that are running on the hardware. One that is actually with the actuators and trying to help you with your daily routine, and the other one in the shadow mode, right, where complete stack is running, the beta software is actually tested inside, and we can expect whether this is going to behave correctly or not, right? And when we are done, and we are happy with the results, then we really deploy to the system that is then active, and then we continue with a new version, for instance. So this is something that was really from a safety and technology point of view not possible in, I don't know, 10 years ago, because then the machine was too big, too hot, too many engineering problem, dissipation, energy, whatever, right? That now it's so tiny, small. The silicon is super tiny and cheap enough that you can put 2 parallel systems in your car and drive like this. This is what for instance, Tesla is doing with the series grade cars.
Mm-hmm.
Yeah, and there are other challenges like with the object detection. Yeah, so it's machine learning and artificial intelligence challenges. You know that actually the driving is still a social process, and we as a humans know a lot about the social science. and we are good in social science recognition. For example, if, I don't know, the cyclist or pedestrian just blinks to you, that means something to you. Either he is going to cross the road in front of you, or I don't know, he's passing you. And yeah, machine learning is now a bit lacking of this intuition. Another example is just the ball on the road. Yeah, so for artificial intelligence, it means that, okay, we recognize the ball, maybe we can slow down and so on. But for us humans, it might mean that there is a kid behind the car, and we can do something more in advance. These are exactly the corner cases that I was talking about, and yeah, we need some time to deal with this.
Now that you mentioned machine learning, we are actually approaching to another question that we got from our attendees. And that is the question: which are the biggest challenges you face regarding projects based on computer vision and machine learning?
So one example is exactly that I shared, but yeah, there's another about the prediction of the movements of different objects. For example, if there is a crowded place, okay, we can recognize that it is a queue or just a crowded people there. But if somebody suddenly wants to jump out of this crowded place, it's hard to predict.
So, well, I think that computer vision, I mean, we can combine it with the next also question: what kind of sensors are you currently using, etc. So with vision, you can achieve a lot, but you cannot really cover everything, right? And where we are talking about human, for instance, human perception, you can detect the objects, you can classify them or identify which kind of object you have. You can actually really, with your stereo vision, you can actually have a really good sensing on the distancing and on the relative position on the objects on the street. You can detect faces, you can detect a lot of different stuff, right? With the cameras, you can do a lot. So cameras are good with a good, let's say, with a good weather, with a good lighting condition. They're really extremely good. You can have different resolutions, you can have different field of view to actually tweak your lenses for particular application, right? So you have a 360 view around the car, you can have the far field camera that is actually trying to detect a car on the highway for 200 meters in front of you. You can have a sign recognition camera that is looking at the right angle and the right resolution, etc. This is all helpful. But you can also have a LiDAR as a laser distancer from the car. Some manufacturers are using it, either LiDAR mechanical or with the MEMS constructions to actually put the lasers with this technology. And you can have the radar, you can have the ultrasonic system as well. For instance, ultrasonic is also used for valet parking situation, where you are moving slowly through the confined space and you're trying to find the parking lot, empty parking lot, and park your vehicle there. So the computer vision, of course, has many different challenges and these occlusions, distortions, and stuff like that. Camera needs to be calibrated properly. If you bump it, then it's decalibrated again, so you cannot use the system. You need to go to a shop to recalibrate it and stuff like this. So it has its own limits. And then what is actually used is a sensor fusion, right? That you rely on multiple sensors, and then machine is trying to actually map this with their own reality, with the model of that is surrounding the car. And then on top of it, we do actually the path planning. We do a lot of algorithms to actually figure out what we want to do with acceleration, brake, and the steering, right? So it's not only about the computer vision, but computer vision is super essential, right? And these challenges, I mean, when you're talking about the machine learning, when you're talking about the DNN, it's all about data, right? So who is having the most kilometers, who is having the realistic models and more data is always welcome. And this is then a big data challenge, that you need to collect your data smart enough, that you have the warehouse to actually store it, and then you need to be able to rerun all the algorithms to know that you're progressing and not regressing in the next version of the software. So you actually do, with all the recorded session, with the simulation, of course, with all the signals, you replay them in either simulated environment or really in the hill environment where the hardware is set on a rack. And then you're able actually to verify that you have a better system with your next release. And this is really quite a big engineering challenge that somebody needs to take care of, right? So we need not only embedded programmers, we need the cloud experts, we need a lot of expertise, right? And a lot of different engineers to actually defeat the problem. So this is really, let's say, it's not a single dimensional problem. We are really dealing with a lot of engineering challenges there. But when we combine it together, we orchestrate it in a certain way, then we're slowly progressing, and then we can actually have a safer system, something that is, let's say, better from a version to version, from a production to production, from a model to model. Right?
Since our time is running fast, I would like to mention just two more things that we find very important for this topic, and that is legal status and regulation for autonomous vehicles as a current state of it, and cybersecurity. So, Evgeni, can you just shortly reflect on legal status and regulation for autonomous vehicles?
Yeah. So actually, I would divide the situation into the several geographical areas. So the USA, the Europe, and the Asia. And actually, in most of the regions, we have L2, level 2 legalized vehicles. So like Tesla. Driver is still liable for all the actions, or almost all the actions. And we have some breakthroughs in the USA in several states, like Arizona or Los Angeles. They're allowing the level 3 of autonomy at some places, and even level 4. It's not the true level 4, like on all the public roads. It's very geographically fenced, but nevertheless. In Europe, it's like Germany, as usual. So they are good at cars and they allow a lot. It's level 3. And in the Asia, I think that there's also level 4 allowed at some places. Still, we don't have the true level 4 cars. You cannot buy them. Yeah, yes. They are kind of prototypes.
Prototypes with a safety driver inside, but there are significant now kilometers without the intervention that are actually quite impressive from some of the let's say prototypes. So it's still there, but then we are really talking about the decimal places of these safety and improvements, how to actually converge slowly to something that can be really on the market, that you can buy and put in your garage without actually a proper, let's say, guidance or engineering force that will fix it or update it and stuff like this.
And before the final questions, which are, I assume, the most important also for our participants, and that is the possibility for them to take part into software development for autonomous vehicles, I would just like to ask you to briefly reflect on cybersecurity, which was also one of the questions from our participants, and also something that is important for this topic. But just briefly, so we can finalize the conversation and then leave some time for questions in chat. So cybersecurity, who would like to answer? Evgeni, maybe.
I can only say that cybersecurity is super important from the day one. Yeah. So yes. You know that the price of the hacking and intervention is really high. and there are different standards and I don't know, different measures that companies implement in the whole process. And as it's safety critical system, there are a lot of guidelines, a lot of rules how to prevent these interventions and so on. So I don't know, Nenad, maybe you can add
right. So the
something
cybersecurity needs to be included from, let's say, from embedded side of things. So it needs to be guaranteed with a certain, let's say, mechanisms on the hardware itself. So encryption, protection from the memory and stuff like this. But also one aspect that is quite important, and actually all the hacking on the world was done through social hacking. So for instance, we are in these companies working with the strict information security systems as well, that nobody can come from the street and steal the data, for instance, and we have the clean desk policies and stuff like really trying to be strict about the let's say the leakage of some of the critical details of such system, where we are really working with the OEMs. We have the NDAs and a really serious contract that between us, when we exchange that the data is safe, for instance, and that we can actually respect the security from this point of view. From a cybersecurity challenge actually increases with every line of code, with every extra ECU or a processor that you put into a car. The connection to the system is then more vulnerable, right? And then, of course, when we connect it to the internet, then all bets are off. So this over-the-air update and the connected vehicles and etc., this is really the critical, let's say, field of research right now. And some authors are really against it. Some authors are more, let's say, optimistic on the topic, and we really need to be careful. But the main message, as Evgeni said, we need to worry about it from the day one. It's actually built in the system, that we have the security managers, security expertise within the team that is actually enabling us to secure the system, but also looking from all the critical points and angles and do the many testing, performance testing, penetration testing, and etc., that is proving that this system is secure. And with everything and all the measures, still there are going to be smarter guys than us, right, that can do the malicious things. When you have a car on the street and somebody can access it, every lock is breakable, and you cannot really have something that is unpenetrable, right? Then it's a question, right? When this thing is detected, it's better to disable it then, where the malicious software is actually entering the car. The best thing is to turn it off, and then you need to go to expensive intervention, probably to the shop. And this is not something that people will not like. But right now, we can expect more of it in the upcoming years.
Unfortunately, we are approaching to the end of conversation, which of course is not the end of our webinar, because we have a lot of questions to answer. I would like to reflect on this, let's say the last chapter that we have, because we got a lot of questions from our attendees about which programming languages do you recommend for someone who is starting his career in automotive? Also, what technical background and level of it should a person have to enter in the development of these technologies? So, Evgeni, can you please answer this question, since our company is also like Nenad's company is working with these technologies?
Yeah. So it really depends on the tasks that you want to solve, because as I mentioned, there are a lot of them, and automotive is really wide area. But basically, my recommendation would be, if you want to develop the code that will be flashed into the car, it's good to understand and learn C and C++. I would be more focused on C++. But also there are many tasks around the target code that is going to the car, like it's covered on Python and even other less famous languages. And the language here is just the instrument as in every other area. Also nice to have is to understand the autonomous systems in general and the platforms like AutoSAR. AutoSAR is the automotive open source architecture. So there are many courses or YouTube videos that you can watch and get familiar with that. Essential also the test-driven development and continuous integration. So we try to be agile, as much agile as possible. So understanding of Scrum and Agile in general is also nice to have.
For people of, I'm not sure who exactly our attendees are, but I assume that there are also juniors and students. I would like to highlight that Luxoft currently is holding 2 programs for students, and we are planning to continue with this practice in future. One of the program is with the Faculty of Organizational Sciences, and the other one is with the School of Electric School for Electric Engineering at TTTech. So also that is the let's say the possibility for juniors and students to join us one day, attend the course, and maybe get employed in our company afterwards. And also we got a question from one of the participants. Let me just find it. Someone from Faculty of Technical Sciences. Nenad, since you are a professor at the university, the question is, as someone who graduated from the Faculty of Technical Sciences, what are the chances of being offered a job in your company if I don't have a formal education in the field of electrotechnics?
Right. So of course, I can recommend the Faculty of Technical Sciences. I mean, I'm biased, of course, but also this cathedra, right? So RTRK also is still, let's say, a department which is having the full automotive curriculum on a master level. So we offer the full courses in this mentioned AutoSAR and actually processes of development in the car, computer vision, deep neural networks, and etc. And this is a path that I can recommend for somebody that is figuring out what to do for the master degree. Of course, with this master program, we are happy to have you. Of course, there is also NIT Academy in Novi Sad, based in the NTP, that is offering the courses that are specific to functional safety, also agile and etc., where you can actually find a good lecturers, myself included, with somebody that is coming from the field and actually speaking from a first hand what is we have for the industry. This is usually done with a hybrid mode, so some of the things, everything is done online, right? And some of the lectures are actually live. And what is really essential, that you have a mentor with you to complete a mini projects inside and help you through the curriculum and to guide you toward the completion of these courses. The big point here that is one of the questions as well from the audience is whether we can actually do it from Serbia. Of course, here exactly. we are doing it. We are doing it for quite some time. We entered the arena from infotainment business. Also, this was really modern back then to have an Android system in the infotainment. Then we slowly moved into automotive. For instance, I don't know if you know, but TTTech together with RTRK actually worked on a project ZFAS for Audi, and this is really in A6, this is the technology that is there from 2017, right? So this complex system was actually partly developed also from Novi Sad, for instance. So this is not a science fiction. This is really our reality, and we are happy to promote it more, and of course include more developers, include more companies, have a big healthy ecosystem that we can help each other, like this webinar, for instance, and that we can exchange all the good practices, and of course attract more talents, and of course make these breakthroughs that we all hope for.
Yes, I actually wanted to reflect to this question that we got, but you mentioned that is Serbia able to follow trends in automotive? Of course, our companies are here. I would like to emphasize that you can find the vacancies for Luxoft at HelloWorld website as well, also at our career page. So feel free to visit and see if there is something interesting for you, and feel free to contact us in that case.
And I can also just add a couple of words. So I would really like to encourage you to don't limit yourself, because if you don't have even the specific education, formal education, it's not the problem. I mean, if you have enough knowledge from other sources, or what is more important, if you have a proactivity and passion, you have a higher chances, you know.
Yes. Very, very well put.
So I think this is unfortunately the end of our conversation in this manner, but we have a lot of questions, which really makes me proud. And as I can see, the number of participants doesn't decrease. So that means that we covered the interesting part of this huge topic. So as I can see, sorry, now I need to scroll, but as I can see, Evgeni already answered some questions. But Nenad, Evgeni, is there any question that you see that you can ask? What is the future? Vladimir asked, what is the future of autonomous car technology, and what new breakthroughs can we expect to see in the years ahead? And what is the ethical consideration involved in developing and deploying autonomous car technology? So,
Evgeni, if you want.
I just want to mention that, yeah, we need to be very careful with our forecast. So maybe a good forecast is that level 4 will be widespread in maybe 10 years, 5 to 10 years. But let's see. So it's actually you and we who are
we need to do it together.
Yeah.
So some let's say some analysis actually showed that it's the same complexity to achieve real level 3 and level 4. Some authors are also persuading to actually drop completely this taxonomy and these levels and adopt some new ways of thinking. But not to derail too much, to try to answer also the second question. The ethical consideration is with the AI in general, very, very, let's say, vivid one and a very active one. We are now witnessing the ChatGPT. We are now witnessing a plethora of solutions around the globe, and you can also find, let's say, some kind of a global consensus that we need to slow down a bit to figure out how to put more secure and more safety within this system. One inspiring talk that I listened to the other day is that we really need to build in a kill switch to actually be able to stop hardware for harming anyone if we want to aim for this breakthrough, right? Because something can go wrong if we put our lives or our let's say safety in the hands or in the head of a machine, then really we need to be sure that we can also control it and that we are really not let's say not going to enter this famous scene from a Terminator, right? Where machine goes against us. So we are somewhere right now from a philosophical realm on the boundary that we can actually see the vivid manifestation of such a technology, but it's still super stupid. It's a trickery, and you're not really having a real conversation. It's just an approximation or condensed version of internet that is talking to you. That's what I can tell about ChatGPT, for instance. So ethical consideration, whether you can actually make a decision if you are going in the front load collision, who to kill, a pedestrian or a driver, this is unsolvable. We cannot really put an algorithm to decide that, and some things will just be unsolved.
Another question that we got from Miloš Acimović is, do you think that the problem is supposed to be and should be handled with an end-to-end model, or do you think it must be broken down into multiple models?
So end-to-end, if we are talking about end-to-end deep neural network approach, right? There are certain concepts, and even you can, for instance, comma AI. So you can buy a phone-like device, and you can attach it on your can and place it in instead of mirror, right? And you can actually enable one end-to-end system that is really running on the processor with the computer vision drive that is actually comparable from let's say from a performance point of view with the current Tesla models. So you can buy that for, I don't know, $2,000 and put in many different cars. So check out comma AI. This is the end-to-end approach. My take would be that with the end-to-end approach, we will actually have a certain limit because of this convergence, right? So we can do a lot of stuff, but we are not sure actually how to make more progress. We're not sure what machine as a black box is doing. And then me, engineering in me, would like to decompose a problem and try to resolve the problem without actually this end-to-end approach. But this is maybe just me. I mean, let's see who will win.
Another question from Slaviša Savić. How applicable are current technologies to another vehicles? Can we expect, for example, motorcycle with sensors that will reduce speed, activate brakes in situations of potential accident? Evgeni?
So yeah, this is actually, I didn't expect such a question, very interesting one. And so we are focusing on the cars, so I don't know a lot about these technologies. I know that there are at least startups that are doing this for motorcycles. From the other hand, there are a lot of other vehicles like trucks and even fleets of trucks, like they are going one by one autonomously and deliver the goods more efficiently without the driver. So answering the question, yeah, for motorcycles, there are definitely something is going on the same as for the autonomous vehicles.
We have a question from Radovan regarding C and C++. Evgeni, did you answer already this question about C and C++? So I should not.
If I got the question right, I answered.
Did you answer to Radovan's question?
We can ask actually Radovan if I answered his question or I didn't get it right.
Right. So I can speak up with a general topic, right? If we are talking about the embedded system in general, I mean, there is no better way to actually deal with a bare bone machine other than addressing it with a C and C++. Even if you want to do something in Python, it's mostly written in C. So don't be fooled by high level languages still. So C and C++ are very, very important to be, let's say, well written, well known. And of course, C++ is also quite, how to say, quite live and still evolving. You can check out the CPP-Con, check out some of the authors there as well, because we can also talk about really modern C++, not the C++ from 20 years ago. So check it out. It's super important. We mentioned AutoSAR, for instance. So AutoSAR Classic platform, which is really the bare-bone platform, is practically written in C. And now we have adaptive platform, service-oriented approach, which is written in C++. So these are the two really the really important languages and technologies that are used to actually build the software in the car. Everything else, it's also important, but maybe not directly put into the car itself or on the processor on the ECU.
Yugoslav asked the question about car hardware simulator. I think Evgeni already answered this question. Maya asks about the ChatGPT. Evgeni, did you see that question?
On the ChatGPT, does LLM really give us?
Yeah, does the LLM really can give us the answers we need, or he just writes B+ school papers?
I answered with a B-. I will not give it even a B+.
You answered, okay.
But it's really. Oh, sorry, I misspelled Radovan. I'm a bad typer. So what really ChatGPT is doing is really condensing a lot of written natural language from the internet, Russian and Serbian included. You can actually have let's say, a conversation with it, but you're really speaking with a history captured from the internet. So somebody answered a similar question, and then this clever algorithm is trying to combine it. I was fooled when I tried to use it, and I was generating a lot of stuff. It was helpful really as a tool to do some, without Googling, to do some research and stuff like this. And then I figured out when I want actually the exact answers, like for instance, ID of a digital ID of a document, ChatGPT will give me the ID, which is completely imaginary, right? It's not existing really, but it's an answer. And then with a disclaimer from this answer, the answer comes with a disclaimer that you should actually use something else for this activity and not ChatGPT. So I think it's a really let's say spectacular advancement now, but we still need to understand let's say the guts of it and what is really what is actually in front of our eyes, and not to fool ourselves that this is a real intelligence.
I can see this conversation about interpretation of Radovan's question. I would actually like to read Radovan's question just to find it, so we can finally answer to him. Radovan said, you mentioned C and C++ as basic languages in automotive industry. What are best areas or jobs, if you can mention few, in automotive for the people who have basic knowledge in C++ and want to continuously improve it and also work in automotive in their future career? So what is some kind of entry positions, as I understand, for someone who has C++ and C knowledge?
For TTTech, it's quite simple: junior developer.
Yeah, so I cannot be more like specific here.
So junior developer, and of course we will aim you toward the performance host, right? So this modern architecture where the C++ is important, the C is important for microcontrollers, right? And this is really where the safety critical stuff is, that is monitoring the big brain of operation, the performance host, where the things are more, let's say, more modern or more dynamic, and there we use C++ and their paradigms, templates, and the stuff that are mentioned in the chat. Boyan,
I cannot see well, is asking us to tell more about the positions in companies in case someone is interested. As I said, you can check our Luxoft profile at Hello World and see the positions. because I assume it's quite hard to discuss positions since we don't know the level of your knowledge. So basically, you can always check out our profile, and all the vacancies are there. And someone asked about the Python that I think Evgeni already answered. Yes, the people who have basic Python knowledge, how can we move to automotive industry?
Yeah, actually we have just the pure Python positions as well. So on Python, we can do the prototyping of algorithms. On Python, we can do data pipeline optimization and so on. So many tasks, despite that the target code is written in C and C++. So there are a lot of work related to the automotive and software development there in Python.
And for us, majority of our, let's say, proprietary stuff, this internal product that we call MotionWise is actually written in Python. A lot of code generators, checkers, and etc. that are necessary to offer to OEMs best possible application layer. This is all written in Python. I think we somehow skipped a question from a security point of view, and this quantum protocol. I need to be honest. I googled it out. Yes, this is the cryptographic protocol, and this cryptography, or the whole, let's say, security topic. This is something that is necessary to be enabled with the hardware that is going to be inside the car. But I don't know, other means of communication that are also essential here. We also can see from a Web3, for instance, where you have this now modern consensus algorithms. So for instance, I can imagine that consensus algorithm can be helpful to figure out this ambulance approaching scenario, that you can have a consensus for multiple cars within the area that this is actually really happening, for instance. Not consensus in terms of, let's say, a Bitcoin mining and coins, but a consensus to have a collective, robust idea or a model about the system in the surrounding area, and then you make some kind of a decisions on top of it. So security, quite essential. Unfortunately, I'm not the cryptography expert. I cannot really directly answer on the QKD. The questions from Maya, maybe we can exchange after the call and try to stay in contact to explore the idea and learn some more.
Yeah, and maybe next time we can also cover one interesting topic in which I'm not also too deep into, but nevertheless it's very promising, the introduction of blockchain into the automotive. And it can help us with the security as well.
Now that you mentioned the next time, I must say that obviously we will need to have the next time part 2 of this webinar, since but really joke aside, I'm very glad that we covered all the topics that we planned, or majority of them, answered all the questions. I think we've covered everything. Our apologies to people who are left without answer. Unfortunately, we are running out of time, but it seems to me that the number of participants didn't decrease, and that we covered many things, and there are many things left. So maybe we cannot promise, but maybe we will have a continuation of this webinar in the future. Thank you very much for participating, Nenad and Evgeni and Bojana. Thank you very much, and thank to all attendees. I would like to invite you to share your opinion tomorrow with Bojana, to share your opinion on this webinar, and if we get the positive feedback, we can organize something again, and for sure we would like to do that. Thank you very much once more.
Thank you for the invitation. Yeah.
Thank you very much
for an interesting talk.
Thank you, everyone,
thank you for the opportunity, and of course, let's stay tuned, stay in touch, and of course, enjoy the ride.
Exactly.
Have a nice evening.
See you.
Nice evening.
Goodbye.
Bye-bye.
Bye.
Bye-bye.